Hello everyone, in this video let us solve this question. So we have root x raised to power x is equal to 2 raised to power x plus 16, and here we have to solve for the value of x. So x is the unknown we have to solve for. To solve this, solution. So we have root x raised to power x equals 2 raised to power x plus 16. Now, the first thing we're going to do is to apply this rule of indices, that if you have root a, this equals a raised to power 1 over 2. So applying this rule right here, this becomes into bracket x raised to power 1 over 2, all raised to power x. This equals 2 raised to power x plus 16. So, also applying this rule of indices, that if you have a raised to power m, all raised to power n, this equals a raised to power m times n. Applying this rule here also, what we have is this: we have x, then x will multiply 1 over 2, so x times 1 is x over 2 equals 2 raised to power x plus 16. So at this junction, we are going to introduce natural logarithm to this equation. So we have ln x raised to power x over 2 equals ln 2 raised to power x plus 16. So with this, applying this rule of natural logarithm, that if you have ln a raised to power m, this equals m times ln a. Applying this rule here, this becomes x over 2, then times ln x is equal to, also applying this rule here, we have into bracket x plus 16 multiplied by ln 2. So with this, x over 2 times ln x is equal to ln 2. We open the bracket by multiplying what is in the bracket. So we have x times ln 2, then plus ln 2 times 16, that is 16 ln 2. With this, we are then going to move x times ln 2 over to this side. Then we have x over 2 times ln x, then minus x times ln 2. This equals 16 times ln 2. Now, at this junction, we are going to multiply this equation by 2. So we have 2 into bracket x over 2 times ln x minus x times ln 2 is equal to 2 multiplied by 16 times ln 2. Now, from here, 2, we open the bracket, 2 times x over 2 times ln x, that will give us x times ln x. Then 2 times minus x ln 2, that will become minus 2x ln 2 equals 2 times 16, 32 times ln 2. Now, from here, we have a common factor, x. So factorize out x into bracket. We are left with ln x minus 2 ln 2 is equal to 32 times ln 2. Also, at this junction, applying this rule of natural logarithm, that if you have m times ln a, this equals ln a raised to power m. So applying this rule right here, what we have is this: x into bracket ln x, then minus ln 2 raised to power 2. This equals 32 times ln 2. From here, x into bracket ln x minus ln 2 squared is 4 equals 32 times ln 2. With this, we are going to apply this rule of natural logarithm, that if you have ln a minus ln b, this equals ln a over b. Okay, so applying this right here, what we have is this, that x into bracket ln x over 4, all of this is equal to 32 times ln 2. With this, we are going to then divide this equation by 4, divide this by 4, such that we have x over 4 times ln x over 4, and this is equal to 4 here 1, 4 we divide 32, we have 8, so equal 8 times ln 2. So from here, we have x over 4 times ln x over 4. This equals, it can be written as 4 times 2, then times ln 2. So x over 4 times ln x over 4. This equals 4 times. Applying this rule of natural logarithm, that if you have m times ln a, this equals ln a raised to power m. Applying this right here, what we have is this. We have times ln 2 raised to power 2. So we have x over 4 times ln x over 4, and this equals 4 times ln 2 squared is 4. Okay, so to then solve this further, we are going to apply the Lambert W function, which is given by, if you have an expression of this format, a times e raised to power a. Once you apply the Lambert W function W, what we get is a. But then, in order for us to apply this Lambert W function, we are going to bring in this function, that if you have e raised to power ln a, this equals to a. So instead of writing x over 4, we're going to write e raised to power ln x over 4. We will still get x over 4, then times ln x over 4. This equals, also, instead of writing 4, we're going to write down e raised to power ln 4. You will still get 4, then times ln 4. Now, looking at this Lambert W function, you will notice that e is in the second place. So move this e to stay in the second place. We have this. So we have ln x over 4 times e raised to power ln x over 4 is equal to, same thing here also, move e to stay in the second place. We have this equals ln 4 times e raised to power ln 4. Now, we can then apply the Lambert W function to this equation. So we have W into brackets ln x over 4 times e raised to power ln x over 4 equals W into brackets. We have ln 4 times e raised to power ln 4. Applying the Lambert W function to this, what we'll get is ln x over 4 equals, same thing here also, the value equals ln 4. So at this junction, we have this, we have ln x over 4 equals ln 4. To then solve for the value of x, we are going to apply this rule of natural logarithm, that if you have ln a equals ln b, this means that the value of a equals b. So applying this right here, what we have is x over 4 is then equal to 4. And from here, simply cross multiply. X times 1, x equals 4 times 4 is 16. So with this, we have gotten the solution for the value of x equals 16. Now, if you enjoyed the video, don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.